Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be working out some practice questions that are going to closely mirror what you'll see in the Arithmetic Reasoning Subtest of the Armed Services Vocational Aptitude Battery, as well as the Air Force Officer Qualification Test, that is the ASVAB, as well as the AFOQT, respectively. In order to get the most out of today's video, I strongly encourage you to make an effort to work out all the practice problems on your own. That is, after I read a question, you should pause the video, attempt to work it out on your own scratch paper, and then resume playing the video to check your solution. On both the ASVAB as well as the AFOQT, you're not allowed to use a reference sheet or a calculator, so try not to use any of those resources as you take this practice test. Finally, I want to mention that in the description of this video, I'm going to include timestamps that correspond to each question. Next to the timestamp, there's going to be a topic that the question's testing. And next to the topic, you'll find a link to a video where I discuss that topic in greater detail. So if at any point during this video you get stuck or you need additional help, just look in the description of this video. There you'll find additional resources. So all those things being said, let's go ahead and get started with today's video. Question 1 says Dirk is paid a yearly salary of $18,000. His monthly paycheck shows the following deductions: federal income tax $292.20, FICA $91.95, state tax $42.45, and pension $432. What is his yearly take-home pay? So in this case, we're going to add up all the deductions and subtract that from his yearly salary. This problem's pretty straightforward. That said, we're going to have to add up these decimals, and the best way to do that is to line them up vertically so as not to make any mistakes. So we have 292, 20, 91.95. So right here, I'm going to line up these decimals vertically. Then we have 42.45. And finally, we have 432. So let's go ahead and add these up. Take your time as you do this. This is where most people make mistakes and get these simple questions wrong. It's very easy to copy down the wrong number over here. So we have 5 plus 5, which is 10 plus 2. So we're going to drop down a 2 and carry a 1. Now we have 7 plus 9, which is 16, 17, 18, 19. So we're going to drop down a 9 and carry a 1. As far as this decimal goes, we're just going to drop it down in place. Now we have 4 plus 2, which is 6, plus 1 is 7, 8, 9, 10. So we're going to drop down a 0 and carry a 1. 9 plus 9 is 18, 19, 20, 21, 22, 23. So drop down a 3 and carry your 2. 2 plus 2 is 4. So we can see that in total, he has deductions in the amount of $430.92. Now this is per month. So what we're going to have to do is take this $430.92 and multiply it by 12 to convert this to a yearly deduction amount. So let's go ahead and do that. Again, we have 430.92 times 12. And as you can see, we're multiplying a decimal by a whole number, notably 430.92 by 12. In order to proceed, we want to rewrite this decimal as a whole number as well. So in order to do that, we're going to take this decimal and shift it 2 times to the right to make that 43092. I'm going to take note of how many times I moved that decimal. I moved it 2 times. And then I'm going to multiply it by 12. Once I do this arithmetic right here, I'm going to shift that decimal back into the left 2 times to make up for the fact that I moved it over here. So let's go ahead and work this out. This is 2 times 2, which is 4. 9 times 2, which is 18. So drop down an 8, carry a 1. 2 times 0 is 0. plus 1 is 1. 2 times 3 is 6, and 2 times 4 is 8. Before we start multiplication with this 1, we have to bring down a 0 placeholder. 1 times 2 is 2. 9 times 1 is 9. 1 times 0 is 0. 1 times 3 is 3. And 1 times 4, of course, is 4. Let's go ahead and add this up. 0 plus 4 is 4. 8 plus 2 is 10, so we're going to carry a 1. 9 plus 1 is 10, plus 1 is 11, so bring down a 1, carry a 1. 6 plus 1 is 7. 8 plus 3 is 11, so carry your 1. 4 plus 1 is 5, and as I said, we're going to shift those two decimals back in. 1, 2. So in total, he has yearly deduction in the amount of $5,171.04. Now that we figured that out, we can take this amount and subtract it from $18,000 to figure out how much he takes home every year. So let's go ahead and do that. And I'm going to do that off to the side over here. Again, that's 18,000 minus 5171.04. Now, as you can see, we're subtracting decimals now. In this case, 18,000 doesn't have a decimal in it, which is fine. We can write decimals in 18,000 by placing a decimal point there and bringing up 2 zeros. So as you can see, we're starting by subtracting 0 by 4, which we can't do. So we're going to have to come all the way over here and borrow from this 8. This is going to become 7. This is going to become 10. This is going to become 9. This will become 10. Again, this will become 9. This will become 10. 9, 10, 9, 10. And now we can proceed. 10 minus 4 is 6. 9 minus 0 is just 9. Drop down your decimal in place. 9 minus 1 is 8. 9 minus 7 is 2. 9 minus 1 is 8. 7 minus 5 is 2. And 1 minus nothing is 1. So we can see that after we take away his yearly deductions, he's left with $12,828.96, which is A. Again, this is a simple problem. That said, we had to add with decimals, multiply with decimals, and then subtract with decimals, which made it very tedious. And you'll find that that's the case for the arithmetic reasoning subtest. None of the questions are going to be too difficult. That said, you can get bogged down with doing these very simple operations over and over again, so you have to be good at doing them. All right, so let's move on to number 2. All right, question 2 says, if 400 people can be seated in 8 subway cars, how many people can be seated in 5 subway cars? On the ASVAB and the Air Force Officer Qualification Test, you're going to have to use proportions a lot to quickly solve some of these problems. And in this instance, I can use a proportion to easily solve this one. Generally, when I work with proportions, I like to write everything that I'm given on the left-hand side of the proportion and everything else on the right-hand side of the proportion. As you can see, we're told that 400 people can be seated in 8 subway cars. So on this left-hand side of my proportion, I'm going to write 400 people. And in the denominator, I'm going to put 8. And I'm just going to call them cars, since we both know they are subway cars. And now we have our equal sign. And as we fill in this right-hand side of the proportion, we want to keep things proportional. That is, since we have cars in the denominator on the left-hand side, we're going to put cars in the denominator on the right-hand side. And likewise, we're going to put people in the numerator. So let's go ahead and do that. If we look here, you can see this question asks how many people can be seated in 5 subway cars. So we're going to put 5 cars here. And to represent the unknown amount of people, we'll call this X people. As long as you keep these things straight, it really doesn't matter how you set up your proportion otherwise. I could have put cars in the numerator if I wanted to, and that would have prompted me to put cars in the numerator over here. As long as you keep those things straight, these problems you'll get these problems correct. But as our next step, we're going to cross multiply, and I'm going to cross multiply with this unknown variable first because it's going to keep x on the left-hand side of the equation, which will make it a little bit easier to work with. So I'm going to do 8 times x first, so that's going to be 8x. Then I'm going to do 5 times 400 next. So that's 5 times 400. This math's pretty easy to do mentally. This is 8x equals, again, 5 times 4 is 20, and just tack on those 2 extra zeros. So this becomes 8x equals 2,000, and now we're just going to divide both sides by 8 to get x by itself. This is going to cross out, leaving us with just x over here, and now this is 2,000 over 8. All fractions can be regarded as long division, so instead of reading this as 2,000 over 8, we can actually read it as 2,000 divided by 8. Now, if you wanted to, you could have simplified this prior to doing this long division, but either way, it doesn't matter. This math's pretty easy to do. Now we're asking ourselves, how many times does 8 go into 2? It doesn't. How many times does 8 go into 20 without going over it? That's 2 times, given that 8 times 2 is 16. Now we're going to subtract. 20 minus 16 is 4. Drop down that 0 and drop down that 0. 8 goes into 40 5 times without going over. Therefore, 8 goes into 450 times without going over. 8 times 50 will be 400 evenly. 400 minus 400 is 0. And so we can see x in this case is 250. And if you want, you can look back up at your proportion, and we know x corresponds with people. So this is 250 people. In other words, 250 people can be seated in 5 subway cars, and we can see that that answer choice is B. All right, number 3 says Tim weighs 243 pounds. If he loses 3 pounds per week, how much will he weigh in 7 weeks? This is a pretty easy one to figure out. We're just going to do 243 minus 7 times 3, and this will tell us how much he weighs after losing 3 pounds for 7 weeks. So this is 243 minus 7 times 3, which is 21. You should be able to do this in your head, but if you want to play it safe and work it off to the side, you can. This is 243 minus 21. 3 minus 1 is 2. 4 minus 2 is 2, and 2 minus nothing is 2. So we can see that after 7 weeks, he'll weigh 222 pounds, which again is B. All right, number 4 says a blueprint has a scale of 3 feet per half inch. If a bathroom is 1.5 inches by 2 inches, what are its actual dimensions? So in this case, we can actually use 2 proportions to convert 1.5 inches as well as 2 inches to be in terms of feet and according to this scale. So let's go ahead and get those proportions set up. Again, I like to take what's given and place that on the left-hand side of the proportion. So what's given is 3 feet corresponds with half of an inch. So let's go ahead and fill in one of these proportions. Again, I want to convert 1.5 inches to be in terms of feet and according to the scale. As we can see, I put inches in the denominator here. So I'm going to put 1.5 inches in the denominator over here to keep these proportional. And then I'm going to call this x feet since we don't know how many feet that converts to. Then I'm going to set up a second proportion. And again, I'm going to put what I know in the left-hand side of the proportion. Notably, 3 feet corresponds to half of an inch according to this scale. And then we want to convert according to the problem 2 inches, and we want to know how many feet that's going to be. And by solving these two sets of proportions, we'll be able to make these conversions accordingly. And as you probably know by now, we're just going to do some simple cross multiplication. And I'm going to do 1/2 times x first. So this is 1/2. X equals 1 1/2 times 3. So that's 1 1/2 times 3. Let's go ahead and work this out before we go any further. As my next step, I'm going to take this mixed number and convert it into an improper fraction before I multiply it by 3. Again, since this is a fraction and this is a mixed number, we do have to make a conversion at some point to make this math a little bit easier. And I'm going to go ahead and do that right now. So I'm just going to copy down 1/2 x equals. I'm not going to do anything with this just yet. To convert this mixed number to an improper fraction, you do 1 times 2, which is 2 plus 1. So this becomes 3/2 times 3. And now we got to do this multiplication with a fraction and a whole number. That's actually pretty easy to do. If you place this whole number over 1, it's now a fraction itself. And now to multiply fractions, all you do is multiply straight across. And let's go ahead and work that out as well while we're here. So this becomes 3 times 3, which is 9/2 times 1, which is 2. So we've made conversions that are going to make this math a little bit easier. Now we want to get rid of this 1/2 x. So we're going to take that and multiply it by its inverse, notably 2/1, which will prompt these to cross out, leaving us with just x. And we're going to do that to both sides. So we're going to multiply this side by 2/1 as well. And that's going to cross out here and here. So this becomes 9/1, which is just 9 or 9 feet. Again, we can see x corresponds with feet. And if we take a look at our answer choices, we can now cross out all the ones that do not have 9 feet in them as an answer choice. I'm going to say the correct answer is E, since this is the first pair in the dimensions. So let's go ahead and work out the other proportion just to confirm that. Again, I'm going to do this multiplication first, notably 1/2 times x. So that's going to be 1/2 x equals 2 times 3, which is 6. Now we want to get rid of this 1/2, so we're going to multiply both sides by 2/1. This is going to cross out here, leaving me with just x. And this just simply becomes 6 times 2, which is 12. Again, x corresponds, as we can see in our proportion, to feet. So this is 12 feet. In other words, we know the true dimensions of this. What is it, a bathroom? Let me check that. Yep, the true dimensions of this bathroom are 9 feet by 12 feet. And that is, in fact, E. So again, already in this practice test, we've had to use proportions 3 times. Twice in this problem and once in the other problem. So again, get good with proportions. You may notice that we've had to deal with a lot of mixed numbers, fractions, and decimals already. Again, you should expect that on the arithmetic reasoning subtest. All right, number 5 says a rectangular bin 4 feet long, 3 feet wide, and 2 feet high is solidly packed with bricks whose dimensions are 8 inches by 4 inches by 2 inches. The number of bricks in the bin is. So to figure this one out, we're going to take the volume of the rectangular bin, which I'm going to call volume of RB for rectangular bin. And we're going to have to divide that by the volume of an individual brick, which I'm going to call volume of B. Now, right away we should realize that we have a little bit of a dilemma here. Whereas the dimensions of each brick is given in terms of inches, the dimensions of this rectangular bin is given in terms of feet. So at some point, we're going to have to make a conversion either of inches to feet or feet to inches. And I'm just going to do that right off the bat before I do any multiplication and division. So again, this is pretty easy to do. There are 12 inches per foot. So to convert feet to inches, we'll take 4 and multiply it by 12. 4 times 12, we should realize, is 48. So in other words, 44 feet is 48 inches. To convert 3 feet to inches, we're going to do 3 by 12, which is 36. And then to convert 2 feet to inches, we'll do 2 by 12, which is 24. All right, so now that we've made that conversion, let's talk about these shapes that we're trying to find the volume of. In each case, we're dealing with something that looks like this. They're rectangular prisms. And in order to find the volume of a rectangular prism, we use the formula volume equals length times width times height. So in this case, we're going to use this volume formula to find the volume of the rectangular bin as well as the volume of each brick. So let's go ahead and do that. Again, I'm going to do volume of the rectangular bin first. That is going to be what? That's 48 times 36 times 24. And we're going to divide that by the volume of each brick. That's 8 by 4 by 2. Now, some people would actually multiply this entire numerator out and divide it by this denominator. That's fine. You'll get the question right doing it that way. But that said, we got to be smart as we take this test. And we should realize that 36 and 4 have a common factor of 9. In other words, 36 divided by 4 is 9. So we can get rid of this 4 in the denominator and make 36 just 9. Similarly, we should realize that 48 divided by 8 is 6. So we can turn this 48 to 6 and get rid of the 8 in the denominator. And similarly, 24 and 2 have a common factor of 12. So we can get rid of this 2 and make this 24 a 12. So instead of doing all this work, all we have to do is 6 by 9 by 12, which is much easier to do. 6 by 9 is 54. So this becomes 54 times 12. And now we can work this off to the side if we want. This is 54 times 12. 4 times 2 is 8. 5 times 2 is 10. Before we start multiplication with this 0, or this 1, we have to bring down a 0 placeholder. 1 times 4 is 4. 5 times 1 is 5. Let's add these up. 0 plus 8 is 8. 4 plus nothing is 4. 5 plus 1 is 6. So we can see that this is 648. In other words, there are 648 bricks packed into this rectangular bin. Okay, so that was that one. Pretty challenging in light of the fact you had to find the volume of both the bin as well as each brick. And then you had to make this conversion prior to doing any math. And in addition to doing those things, you also had to use some reduction here to make the math a little bit easier and quicker. So that was that one. All right, number 6 says if 2.5 centimeters equals 1 inch and 36 inches equals 1 yard, how many centimeters are in 2.5 yards? So this is a pretty simple problem. We're going to find out how many inches are in 2.5 yards, and then we'll multiply that by how many centimeters there are per inch. So let's go ahead and do that. That's going to be 36 times 2.5, given that we know that there are 36 inches per yard. Therefore, there's going to be 36 times 2.5 inches in 2.5 yards. Again, we're doing multiplication involving a whole number and a decimal. In order to proceed, we're going to take this decimal in 2.5 and shift it one time to the right to make it 25. So in reality, we're doing 36 times 25, albeit with one decimal to shift back into the left at the end. So let's work this out. This is 6 times 5, which is 30. Drop down to 0, carry your 3. 3 times 5 is 15, plus 3 is 18. Before we start multiplication with this 2, we have to bring down a 0 placeholder. 2 times 6 is 12, so bring down a 2, carry a 1. 3 times 2 is 6, plus 1 is 7. So let's add this up. This is 0 plus 0, which is 0. 8 plus 2, which is 10, so bring down a 0, carry a 1. 7 plus 1 is 8, plus 1 is 9. Shift your one decimal back in. So we can see that 36 times 2.5 is 90. In other words, there are 90 inches in 2.5 yards. So now we're going to have to take that 90 and multiply it by 2.5, given that 1 inch corresponds with 2.5 centimeters. So let's go ahead and do this. You could do this in your head if you wanted to pretty easily. 90 times 2 is 180. Half of 90 is 45. 180 and 45 is 225. If I was taking the test, that's how I would do this. But that said, let's say, you're struggling because you get test anxiety. Just stick with doing the math the long way and you'll get the questions right, albeit a little bit more slowly than people who aren't, bogged down with anxiety as much. So let's go ahead and work this out. Again, we're doing a whole number times a decimal. In order to proceed, I'm going to shift this decimal in 2.5 one time to the right to make it 25. So this is the same as 90 times 25. And once I do this math, I'll take that one decimal and shift it back into the left. 0 times 5 is 0. 9 times 5 is 45. Bring down a 0 before you start multiplication with this 2. 2 times 0 is 0. 2 times 9 is 18. Let's add this up. 0 plus 0 is 0. 5 plus 0 is 5. 8 plus 4 is 8, 9, 10, 11, 12. Carry a 1. 1 plus 1 is 1. Or 1 plus 1 is 2. See, I'm worse at arithmetic than I am mental math. 1 plus 1 is 2. Bring your one decimal back in. So we can see that this is, in fact, 225, and this is centimeters. Okay, so that was that one. Again, you could use some mental math tricks to speed up your work, but if you're struggling or you're feeling anxious during the test, just work it out nice and slowly. All right, number 7 says a class of 198 recruits hail from Georgia, North Carolina, and South Carolina. If 1/3 are from Georgia and 1/4 of the remainder are from North Carolina, how many of the recruits in the class are from South Carolina? Okay, so if you want to think about this one as a pie chart, you can. Again, a pie chart is just a circle. Again, we know there are 198 recruits in total, and we know that 1/3 of them, which is about that amount, are from Georgia. In order to figure out how many recruits are from South Carolina, we're going to have to subtract out from 198 the number of recruits from Georgia. So let's go ahead and get that out of the way. That's going to be 198 times, again, 1/3 of the recruits are from Georgia. So that's going to be 198 times 1/3. And as you can see, we're doing multiplication involving a whole number, notably 198, and a fraction, notably by 1/3. In order to do this, we can rewrite 198 as a fraction as well by placing it over 1. And then we'll just multiply straight across. So this becomes 198 times 1, which is just 198. Again, anything times 1 is itself. And then this is 1 times 3, which is just 3. A quick check to tell if 198 is going to be divisible by 3 is to sum all the integers in 198. So 1 plus 9 is 10, plus 8 is 18. 18 is divisible by 3. It's divisible by 3 six times. So we know this is going to work out evenly. Again, we can regard this fraction as long division, notably this. 198 divided by 3. 3 goes into 19 6 times without going over. 3 times 6 is 18. 19 minus 18 is 1. Drop down this 8. 3 goes into 18 6 times evenly. 3 times 6 is 18, so we can see there's no remainder. So in other words, of these 198 recruits, 66 are from Georgia. So let's subtract that out to figure out how many of these other recruits are from North Carolina and South Carolina. So that's going to look like this. 198 minus 66. 8 minus 6 is 2. 9 minus 6 is 3. 1 minus nothing is 1. So let's draw a new pie chart now. And these are just the students who are from, our recruits who are from North Carolina and South Carolina. And we know there are 132 such recruits. And similarly, we're told that a quarter of the remainder are from North Carolina. So a quarter kind of looks like this. We know this quarter's from North Carolina, which means that if there are a quarter who are from North Carolina, the remaining 3/4 are from South Carolina. So to figure out how many of the recruits are from South Carolina, we're going to do 132 times 3/4. Again, there's 1/4 of the remaining recruits from North Carolina, which means 3/4 of the remaining recruits are from South Carolina. Again, we're doing multiplication involving a whole number and a fraction. In order to proceed, we can write 132 as a fraction by placing it over 1. And this will become 132 times 3 over 1 times 4. I have a feeling that 132 is divisible by 4. And if so, we can reduce this prior to doing this math. So let's go ahead and see if it is. 132 divided by 4. 4 goes into 13 3 times without going over. 4 times 3 is 12. 13 minus 12 is 1. Drop down this 2. 4 goes into 12 3 times without going over. 4 times 3 is 12, so there is no remainder. In other words, I can reduce this by this. I can say 4 goes into 4 one time, and 4 goes into 132 33 times, as we just saw. So this becomes 33 times 3 over 1 times 1. 33 times 3 is 99 over 1. Anything over 1 is itself, so this is just 99. In other words, 99 of the recruits are from South Carolina. Okay, so that was that one. Kind of a challenging problem. Again, we have to deal with a lot of fractions, and we have to be mindful of the fact that we had to take away the 66 recruits who were from Georgia to get this second pie chart right here. So let's move on to number 8. I'm going to have to scroll as I read this one. Number 8 says a champion runner ran the 100-yard dash in 3 track meets. The first time she ran it in 10.2 seconds, the second in 10.4 seconds, and the third time in 10 seconds. What was her average time? So to figure out the average of her 100-yard dash times, we're going to add up those times and divide by how many times she ran it. So that's going to look like this. That's 10.2 plus 10.4 plus 10. And of course, that's going to be divisible by 3. Again, to find the average of anything, you sum up the numbers, and then you divide those numbers by how many numbers there are. There's 1, 2, 3 numbers. So let's go ahead and start by summing these numbers. It should be pretty easy to do mentally. 10 plus 10 plus 10 is 30. 0.2 plus 0.4 is 0.6. So this becomes 30.6 over 3. Now, at this point, I'm going to work this out off to the side. Again, we can regard this fraction as long division, notably as 30.6 divided by 3. And this is actually pretty easy to do. Again, when we're doing division involving decimals, as long as the decimal's inside this division bracket, you can proceed as normal. In fact, all you do is have to bring it up right here. And I can see that 30 and 6 are both divisible by 3. 3 goes into 30 10 times, and 3 goes into 6 2 times. Therefore, I know 3 times 10.2 is in fact 30.6 with no remainder. So in other words, the average of her 100-yard dashes is going to be 10.2, which is A. Okay, again, you have to be good at doing this mental math to speed yourself up on this test where possible. So that was that one. All right, number 9 says the length of a rectangle is 3 times its width. If the perimeter of the rectangle is 48, what is its area? So this is a very common question you'll see on the arithmetic reasoning subtest. The best approach I like to take to dealing with it is to draw a little diagram. Again, we know we're dealing with a rectangle, which kind of looks like this. And moreover, we know that in a rectangle, the lengths are equivalent, that is, that side is equal to that side, and the widths are equivalent as well, that is, that side equals that side. According to this problem, we're told the length is 3 times its width. So if I let its width be represented by x, that means its length is 3x, that is 3 times as long. And again, if this side's x, this side's x, of this length is 3x, this length likewise is 3x. In addition, we were told that the perimeter of this rectangle, which I'm going to call P, is 48. In order to find the perimeter of any shape, including a rectangle, you just add up all of its sides. So in other words, the perimeter of this rectangle can be found by doing x plus 3x plus x plus 3x. And as you can see, I just went starting here and added up all of its sides. And again, we know the perimeter is 48. P is 48. So instead of having P here, I'm going to do 48 equals, and I'm just going to add up these x's since they're all like terms. 3x plus 3x is 6x, 7x, 8x. So this is 8x equals 48. To get x by itself, we're going to divide both sides by 8. This is going to cross out here, leaving you with x on this side. 48 divided by 8 is 6. So we can see x equals 6. Let's go ahead and use this value of x to find what the real values of this rectangle are. So let's go ahead and draw another rectangle if we want. Again, we're told the width is x. Well, we know x is 6, so this width of this rectangle is 6. We know the length is 3x. Again, we know x is 6, so this is 3 times 6 or 18. To find the area of a rectangle, you multiply its length times its width. So that looks like this. Again, we know what these values are now. It's going to be 18 times 6. 18 times 6 is 108. So we can see the area of this rectangle is 108, which is D. If you wanted to, you could have worked this off to the side by doing this. But again, try to do as much mental math as confidently and as often as you can. So that was this one. Again, a pretty common question that you'll see on the ASVAB. So be prepared for something like this. All right, number 10 says a butcher made 22.5 pounds of beef into hamburger and wrapped it into 1 1/4 pound packages. How many packages did he make? So to figure this one out, we're going to do 22.5. We're going to divide that by 1 1/4. So again, this is essentially division. Again, we can read this as 22.5 divided by 1 1/4. That said, we have a little bit of a problem here. We're trying to do division involving mixed numbers, which isn't that easy to do. So instead of keeping these mixed numbers, I'm going to convert both of them into improper fractions. I'm going to start with the denominator as I do that. That's going to be 1 times 4, which is 4, plus 1, which is 5. So this one, as an improper fraction, is 5/4. And let's do the same thing for the numerator. 22 times 2 is 44, plus 1 is 45. So this is 45/2. So now we can read this as 45/2 divided by 5/4. In order to divide fractions, you have to follow this algorithm: keep, change, flip. That is, you keep this top fraction the same. So we're just going to write this as 45/2. You're going to go from division to multiplication. So that's our change. Then you're going to flip this fraction in the denominator. So instead of being 5/4, it's going to be 4/5. And now we can go ahead and work this one out. Let me get rid of this work here. And let's try to do some simplification to make this a little bit easier. I know 5 goes into 5 one time and 5 goes into 45 9 times. Similarly, I know 2 goes into 2 one time and 2 goes into 4 2 times. Again, we're just multiplying fractions now, so we're going to multiply straight across. This becomes 9 times 2, which is 18, and then 1 times 1, which is 1. Anything over 1 is itself, so this is just 18. In other words, he was able to make 18 1 1/4 pound packages from the 22.5 pounds of beef of hamburger. So that's this one. Again, pretty challenging insofar as you had to go from mixed numbers to improper fractions, and then you had to divide those improper fractions following the algorithm keep, change, flip. A lot of math packed into one question there. All right, number 11 says, the Pilgrims set sail for Plymouth Rock, which is a distance of approximately 2,800 miles, and the trip took them 63 days. The average speed in miles per hour was closest to which of the following? So right away, we should realize that we're approximating their speed in terms of miles per hour. That is to say, we're not going to work out things fully once we get to the point where we're trying to figure out what the answer is. In addition, we should realize that we have all the elements of the distance formula. We have distance equals rate times time. We can see that distance is 2,800 miles. That's the distance of the trip. We know it took them 63 days to make that trip, so that's time. And we know we're trying to solve for their average speed in miles per hour, so that's their rate. We're trying to figure that out. So before we plug anything into the distance formula, we have to realize that we have a little bit of a conflict here. We're asked to solve for average speed in terms of miles per hour, but we're given time in terms of days. That is to say, there's a little bit of a conflict. So we're either going to have to convert speed to be in terms of days, or we're going to have to convert days to be in terms of hours. Well, as it turns out, it's pretty easy to convert days to hours. Again, there are 24 hours in a day. So in order to convert 63 days into hours, we'll do 63 times 24. And by working this out, everything will be proportional, and we can plug it into the distance formula. So 3 times 4 is 12, carry your 1. 6 times 4 is 24, plus 1 is 25. Bring down a 0 before you start multiplication with this 2. 2 times 3 is 6. 6 times 2 is 12. Let's add this up. 2 plus 0 is 2. 5 plus 6 is 11. Carry a 1. 2 plus 2 is 4. Plus 1 is 5. And 1 plus nothing is 1. So we can see that time is either 63 days or 1,512 hours. Now let's go ahead and plug things into the distance formula. Again, that's distance equals rate times time. We know what d is. It's 2,800 in this case. We know we're solving for rate, so we'll leave that as r. And we know it took them 1,512 hours to complete the trip, so that's 1,512 here. To get r by itself, we're going to divide both sides by 1,512. This crosses out, leaving you at just r here. And as we can see, r equals 2,800 over 1,512. And at the beginning of this problem, I mentioned that they want us to approximate this answer. That is to say, we're not going to divide 2,800 by 1,512. That would take a lot of time. That said, let's look at our answer choices. Half a mile an hour, 2 miles an hour, 3 miles an hour, 4 miles an hour. Again, 2,800 over 1,512 is very close to 30 over 15. 30 over 15 would be 2. If this was 3,000 over 1,500, we know the rate would be 2 miles per hour. Again, this is very close to 2 miles per hour, and so that's the answer we're going to go with. Again, a lot of people might work this out, but again, use your answer choices, and the question even tells you to approximate the answer choice instead of doing this tedious math right here. So that's this one. Number 12 says, if a car uses 1.5 gallons of gas every 30 miles, how many miles can be driven with 6 gallons of gas? Again, we can set up a proportion to solve this one. Again, 1.5 gallons of gas will take you 30 miles. And let's fill in the right-hand side of this proportion now. Again, we're going to keep gallons in the numerator and miles in the denominator accordingly. We're told that we have 6 gallons, so we'll put that in the numerator, and we want to know how many miles that will take you, so we'll regard that as x miles. Now we can solve this proportion via cross multiplication, and I don't know why my pen's starting to act up a little bit. So let's do cross multiplication. Let's do 1.5 times x, which is 1.5x, equals 6 times 30, which is 180. To solve for x, we're going to divide both sides by 1.5 as our next step. This is going to cross out, leaving us with x equals 180 divided by 1.5. In case you can't do this mentally, let's try to work our way through it mentally. I see 18 here and 15 here. I know 18 and 15 are both divisible by 3. So I can reduce 180 and 1.5 by a factor of 3 to make this a little bit easier. 180 is divisible by 3. 180 divided by 3 is 60. And 1.5 divided by 3 is 0.5. 60 divided by 0.5, again, we can now regard this as a fraction. Again, 0.5 is the same as 1/2, so we can write this as 60 over 1/2. And as you may recall, when we divide things with fractions, we use this algorithm, keep, change, flip. So let's go ahead and work this out. Again, this is 60 divided by 1/2. So keep 60 the same. Change this from division to multiplication. And then flip this second fraction. So instead of being 1 over 2, we'll do 2 over 1. Again, anything divided by 1 is itself, so this is 60 times 2, which is just 120. So this one is C. In other words, 6 gallons of gas will take you 120 miles. And we use this proportion as well as some clever mental math here to figure this one out. So again, many ways to solve this right here, but this is how I prefer to do it. All right, number 13 says, Sophie cast a 5-foot long. Number 13 says, Sophie cast a shadow 5 feet long. Her father, who is 6 feet tall, cast a shadow 8 feet long. How tall is Sophie? So in this case, we're going to use another proportion to solve this one. Again, we know her dad is 6 feet tall and cast an 8-foot long shadow. So that looks like this. He's 6 feet in terms of his height, and he cast an 8-foot long shadow. So let's fill in this right-hand side of this proportion. We know Sophie cast a 5-foot long shadow, so let's keep shadows in the denominators. And then we want to know how tall she is, so that's X height. And we saw proportions via cross multiplication. That is, we can do 8 times x, which is 8x, equals 6 times 5, which is 30. Divide both sides by 8 to get x by itself. This crosses out, leaving you with x equals 30 over 8. Prior to doing this long division here, I'm going to simplify 30 over 8. 30 can be divided by, not 15. 30 can be divided by 2, and 8 can be divided by 2 as well. 30 divided by 2 is 15. 8 divided by 2 is 4. Now let's do this long division now that it's a little bit easier to deal with. Again, we can regard this as 15 divided by 4. How many times does 4 go into 15 without going over? That is 3 times, given that 4 times 3 is 12. 15 minus 12 is 3. 4 doesn't go into 3, so we have to add a 0, and in doing so, we have to bring up a decimal. 4 goes into 37 times without going over. 4 times 7 is 28. 30 minus 28 is 2, and now we get to bring down a free 0. 4 goes into 20 5 times without going over. 5 times 4 is 20, so we can see there's no remainder. So we know that Sophie is 3.75 feet tall. Again, if we look at our answer choices, we see that only one of them has 3 feet in it, so we know it's the correct answer. That said, in case they had trickier options here, we should realize that she is 3 feet and 0.75 of a foot tall. Again, that's the same as 3/4. We know there are 12 inches in a foot, so that's 3/4 times 12 over 1. We can work this out pretty quickly. Again, 4 goes into 4 one time, 4 goes into 12 3 times. 3 times 3 is 9, so this is the same as 3 feet 9 inches, which is, in fact, D. Okay, so that was that one. Number 14 says the area of one circle is 4 times as large as a smaller circle with a radius of 3 inches. The radius of the larger circle is. So I'm going to draw some diagrams to help keep my work straight. Again, we have a small circle and a circle that is 4 times as big as this small circle, so it looks something like that. Again, radius is the distance from the center point to the edge of the circle, so those are the radiuses of both circles. We know the small circle has a radius of 3, and we want to know what the radius of this larger circle is. Area of a circle is found by pi r squared. Okay, so in other words, the area of this small circle is area equals pi times 3 squared. That is to say, the area of this small circle is 9 pi. We're told that the area of this larger circle is 4 times that of this smaller circle. So in other words, its area is going to be 4 times the area of this smaller circle. Again, the area of this smaller circle is 9 pi. So this is 4 times 9 pi. 4 times 9 is 36. So we can see that the area of this larger circle is 36 pi. That said, we want to know what the radius of this larger circle is, given that we know its area. So let's go ahead and plug that in over here. This is 36 pi equals pi r squared. And in this case, we're just solving for r now. So let's go ahead and divide both sides by pi. This is going to cross out here as well as here, leaving you with 36 equals r squared. To get rid of this squared, take the square root of both sides. This crosses out, leaving you with just r here. Square root of 36 is 6. So we can see that the radius of this circle, which is 4 times larger than this smaller circle that had a radius of 3, is in fact 6 inches. Okay, so some tricky math there, but pretty straightforward as long as you plug things in accordingly. All right, number 15 says many European cars feature speedometers that show kilometers per hour. If you are required to drive 500 miles and you know that 1 kilometer is approximately 5/8 of a mile, how many kilometers would you cover in that journey? So to solve this one, we're going to set up a proportion. Again, we know the scale, our conversion is 1 kilometer is 5/8 of a mile. So let's write that in as the left-hand side of our proportion. Again, 1 kilometer corresponds with 5/8 of a mile. And we want to know how many kilometers a 500-mile trip corresponds to. So again, in this proportion, we have miles in the denominator. So let's keep it in the denominator here. And we want to know how many kilometers this corresponds to. So let's go ahead and solve this by cross multiplication. Again, I'm going to do cross multiplication with the variable first. So this is 5/8 times x equals 1 times 500. Anything times 1 is itself. So this is just 500. Again, we're trying to get x by itself. So to get rid of 5/8, we're going to multiply by 8 over 5. This is going to cross out here, leaving you with just x. And this becomes 500 times 8 over 5. Again, we can regard 500 as 500 over 1. And we can do some simplification prior to doing 500 times 8 and 1 times 5. I know 5 goes into 5 one time, and 5 goes into 500 100 times. So now let's multiply straight across. This becomes 100 times 8, or 800, over 1 times 1, which is just 1. Anything over 1 is itself, so this is 800 over 1, which is 800. In other words, 500 miles corresponds with 800 kilometers. So that is B in this case. Okay, again, another proportion used to solve one of these problems. All right, number 16 says a landscaping company placed 2 orders with a nursery. The first order was for 13 bushes and 4 trees and totaled $487. The second order was for 6 bushes and 2 trees and totaled $232. The bills do not list the per item price. What were the costs of 1 bush and of 1 tree? So whenever you have to solve for 2 separate things, in this case a bush and a tree, separately, you should realize that you're going to need a system of equations to do so. In this case, we can regard bushes as B and trees as T. So let's go ahead and set up our system. This is going to be 13B plus 4T equals 487. And then this will be 6B plus 2T equals 232. In order to solve a system of equations, you have to either use the elimination method or the substitution method. The elimination method says multiply one of the equations in your system of equations by a constant, add it to the other equation such that you get rid of one of the variables. In looking at these pair of equations, I can see that if I multiply this bottom equation by a constant of -2 and add it to this top equation, this variable of t will drop out. So let's go ahead and do that. Again, we're not changing anything in the top equation, so we're just going to copy that over. That's 13b plus 4t equals 487. As I said, we're multiplying the second equation by a constant of -2, and then we're going to add it to this top equation. -2 times 6b is -12b. -2 times -2 times 2t is -4t. And then -2 times 232, let's work that off to the side. That's 232 times 2, albeit negative, so we'll just bring down a negative there. 2 times 2 is 4, 2 times 3 is 6, 2 times 2 is 4. So -2 times 232 is -646. Let's go ahead and add these two equations. 13b minus 12b is just b. 4t minus 4t is nothing. And then this is 487 minus 464. So let's work that out. That's 487 minus 464. 7 minus 4 is 3. 8 minus 6 is 2. And 4 minus 4 is nothing. So we can see that b equals 23. This b refers to the cost of a single bush. So we can see that bushes cost $23, which if we look at our answer choices, only one of them has that as an option. So we know the correct answer in this case is going to be A. That said, in order to figure out the cost of a tree, we'll take this B, plug it into either of the original equations, and solve for t. So I'm going to plug it into this bottom equation because it's a little bit easier. Again, this bottom equation was 6b plus 2t equals 232. Again, we know what b is. B is 23, so let's plug that in place of this b right here. This is 6 times 23 plus 2t equals 232. In case you can't do this in your head, you can work it off to the side. That's 23 times 6. 6 times 3 is 18, carrier 1. 6 times 2 is 12, plus 1 is 13. So this is 130. My pen is starting to act up. 138 plus 2t equals 232. Again, we're solving for t now, so let's subtract 1/38 from both sides. This crosses out, leaving you with just 2t over here. And as we can see, this is 232 minus 138. 2 minus 8 we can't do. We have to borrow. This becomes 2. This becomes 12. 12 minus 8, 8, 9, 10, 11, 12. That's 4. 2 minus 3 we can't do. We have to borrow. This becomes 1. This becomes 12. 12 minus 3 is 9. 1 minus 1 is nothing, so we can see 2t equals 94. Divide both sides by 2 to get t by itself. And in case you can't do this in your head, you can work it off to the side. Again, this is 94 over 2, which we can read as 94 divided by 2. 2 goes into 9 4 times without going over. 2 times 4 is 8. 9 minus 8 is 1. Drop down this 4. 2 goes into 14 7 times evenly, given that 7 times 2 is 14. So we can see the cost per tree was 47. And I'm starting to run out of steam here. I don't know if you can tell. $47. Again, each bush is $23. Each tree was $47, which again was A. So that is it for this practice test. I hope you found it helpful. Again, some of these questions were pretty challenging, and all of the questions, at least as far as I can tell, took a lot of work to solve. So this should be a good preparation for either of those two arithmetic reasoning subtests. If you like the content I'm creating, please consider subscribing to my channel. In addition, you're more than welcome to leave some feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.